Good morning to everyone. Today we are going to discuss about flexible manufacturing system, that is module 3. So before going on to the flexible manufacturing system, we shall glance at the history, how this FMS has been evolved and what are the reasons for implementing or developing these FMS system. So basically in a production industries, in order to make a faster production and to get the better quality products, this system was very helpful. So for machining purpose and for increasing the production system and for the meeting the requirements of current market, we must be able to develop these FMS. So the FMS was first conceptualized for machining purpose. So this required development of NC machine, that is numerical control machine, because here the main purpose of making this FMS is that so in order to increase the production. So in order to develop this FMS, so it required the development of NC machine, that is numerical control machine, wherein we can able to perform number of machining operations by the help of a program. So basically this concept is credited to David Williamson, so a British engineering during the mid years 1960. So basically the idea came to him in order to develop this FMS, and in 1960 the first FMS machine was installed and it was being tested in the year 1960. So and also the Germany has implemented this FMS in cooperation with the University of Stuttgart. So and later on this was implemented in the 1972. So this is how the system, in order to increase the production rate and also in order to meet the current market conditions, the FMS was developed. So what is FMS? So that is, we know that so in current market, so there is change in the products frequently. So the customer requirements are changing day by day, and also the designs which are made has to be changed frequently according to the convenience of the customers. So the product that are manufactured has to be changed frequently in order to compete in the current market. So what you have done is that so in order to change the design and also in order to change the manufacturing, we implemented this FMS, that is flexible manufacturing system. So here in this flexible manufacturing system, so it has a opportunity to change the design frequently and also to change the manufacturing operations, so that within a less time we can manufacture number of products, and also we were able to manufacture a quality product with less product cost. So nowadays you know that customer require a product with high quality, and also the product has to be of low cost. So in order to meet these requirements, FMS has been implemented and it is being used in the current industries. So we can see that in FMS we are going to use a number of CNC machine, that is computer numerical control machines. Along with that we are going to use some of the flow lines. So there are various flow lines. So depending upon the requirement, depending upon the workspace area, we are going to use the flow lines. And also in FMS we are going to use the automated storage handling system in order to control the production. So flexible manufacturing system is an automated machine cell. So it is going to be consist of number of workstations that are interconnected with automated material handling and storage system. So it consists of number of CNC machine, it consists of number of storage system, and also it consists of a material handling system, so as to make the production faster with good quality products. So for this purpose, this is mostly suited in the industries for producing high volume of products. So this is the reason why you are using these flexible manufacturing system. So why do you require this FMS? So the time delay will be very less because of less breakdowns in the machines. So this is the reason why you are preferring this flexible manufacturing system. So how this flexible manufacturing system is going to make more flexible in the manufacturing industries? So as you know that there are number of capabilities in a manufacturing system. So there must be these capabilities in the manufacturing system, because if the products need to be changed, then we are going to change the physical setup, then we are going to stop the machine, and we are going to make n number of adjustment in the machines to perform or to make changes in the operations. So the ability to identify and distinguish among the different parts, styles processed by the system. So in order to identify the different parts and also the part styles and to process this, the machines that are used must be flexible so that it can identify the different parts, and also in order to change the operation, and also in order to make a different operations and to change over the operations within a less time, the machines must be more flexible, and also to change the physical setup it must be very flexible. So if you are having these flexibilities, then only we can change the product design or change the setup and the operations. So here, by using this flexible manufacturing system, we can able to do all these operations. We can change the physical setup within a short time, we can change the operations, and also we can change the designs, and also we can process a number of ports within a less time. So it is more flexible to use in the industries. So how this FMS is being classified? So these are the classification of FMS. So flexible manufacturing system can be classified according to the number of machines in the system. So obviously if you take one system, then in a system it may be consist of only single CNC machine, or it may be consist of n number of CNC machine, that we are going to call it as workstations. That is, there may be either one workstation or there might be either n number of workstations, depending upon that. So we are going to classify these flexible manufacturing system. So basically the flexible manufacturing system are classified as single machine cell, and also flexible manufacturing cell, and a third one is flexible manufacturing system. So here you can observe the single machine cell. So here this particular single machine cell consists of a single workstation, that is, it consists of only one CNC machining center. So you can observe here, that is, there is a CNC machine where you are going to call it as CNC machining center. So where it has a that is a tool storage, wherein there are number of tools that are present in order to make a number of operations. And also you can see the flow line here. So that is, you can see the pallet wherein it is going to carry the work pieces in order to make a n number of operations. So this flow line is automated, so it is automated and it is going to transfer the finished products to different lines. So when on the pallet the workpiece is stored, then this pallet is going to come to the respective machining center for a respective operation, and it is being carried out by these flow lines. So this single machine cell consists of only one machining center, and it is combined with a parts storage system for unattended operation. So here in this single machine cell, so completed parts are periodically unloaded from the storage unit, and raw work parts are loaded onto it. So that is raw work pieces are being fed and it is being transferred to the machining center to perform the operations, and then they are transferred to the other cells to perform the operations. So depending upon the CNC machine that are used, so we are going to say it as single machine cell, wherein you are going to use the only single machining center here. And the next is a flexible manufacturing cell. So in a flexible manufacturing cell, it consists of 2 or 3 processing workstations. So you can observe in the figure here that it consists of a number of workstations. That is, here in this figure we can observe 3 workstations are present here. That is, it is called as a CNC machining centers and a part handling system. So this part handling system is connected to the load or unload station. So after the operations is performed on the respective machining center, then they are transferred and then they are loaded or unloaded to the respective station. And the final is flexible manufacturing system. So in this flexible manufacturing system, it consists of 4 machining centers or more number of workstations which are connected, so that in order to perform the operations, so these workstations are connected mechanically by a common part handling system. So there is only one common part handling system wherein it is going to transfer the raw materials to the respective workstations, and also these are electronically controlled by a distributed computer system. So this distributed computer system is a system so where all the operations are being controlled. So here if there are number of workstation, for example, if it is having 4 or number of workstations, then by using only one computer system, that is we are going to call it as distributed computer system, we can control all the operations that is being performed, and also we can control the handling system, that is automated metal handling system, in this particular manufacturing system. So the FMS system is having some of the basic components. So that is workstations. That is, in workstations we are going to have a number of CNC machine, that is computer numerical control machines, which are used to perform the machining operations on different families, or it may be part. So here depending upon the parts, that is we are going to manufacture the components, and also it consists of number of storage system in order to transfer the raw materials, and also in order to transfer the finished products. And also it is having a computer control system. So this is how the components of FMS system are present in flexible manufacturing system. So when you come to the workstations, so this particular workstation, so it will be having computer numerical control system, that is, so in order to make up machining operations, so it is having a number of CNC machines wherein it is going to work according to the part families, and it contains number of substations, that is for loading and unloading stations, and also it is consists of machining stations, and it consists of number of assembly workstations wherein after the operation is performed, so in order to assemble the products, so you will be having the assembly workstations, and also other processing stations like inspection, so wherein after making the number of operations, so we have to inspect in a particular workstations. So for that also there is a inspection stations wherein we are going to perform the inspection on the finished parts. So this is how the workstations is going to carry out the work. So it is going to make n number of operations here, whether it may be loading or it may be unloading, or after loading it is going to make the machining operations, and after the respective machining operation is done, so it is finally inspected, and then it is being assembled here. So next is computer control programmable logic controller, that is we have computer control system here. So wherein in the diagram you can observe that, so that is we had a computer here for programming, and also we have the workstation control. So in order to control this particular workstation, so we have a number of units here, that is CPU, memory unit, and we have expansion connection, we have a communication unit, right? And also this particular unit is going to control the traffic, and also it is going to control the material handling system, and also the monitoring of all the work parts that are being processed here. It is going to be controlled by the help of this control system. So this is how the components of FMS are done, that is first is workstations, and second is computer control system. So by this we are able to control, and you are able to make number of operations here. At the same time we have the human resources. So in order to look after all these operations, and also in order to control and also in order to make the operations whether they are being performed like loading the raw work parts, whether the work parts are being loaded into the system or not, and whether the tools are being changed or not, right? And also in order to maintain the required system and to repair the system, we need a human resource department wherein number of skilled persons are present here in order to look after the system and also to perform the overall management of this particular system. So this is the flexible manufacturing system wherein we have machining centers and also we are having a automated guided vehicle wherein the workpieces are being transferred to the respective workstations, and also we have the control room in order to control all the activities, and also we have the loading and unloading station where the workpieces are being loaded, and after the required operations, the workpieces are unloaded. So this is how the flexible manufacturing system is used in the industries. And here also you can observe the 3D view of this flexible manufacturing system, wherein you can see the flow line here and also the number of workstations here. And as I have said that, so human resources are required in order to maintain this particular FMS. That is, humans are needed to manage the operations of the FMS. So there are a number of functions that are typically performed by human, so which include the loading raw work parts into the system and also unloading the finished parts from the system, and for changing and setting the tool or to maintain the equipment and to repair the equipment. So these are the functions that are performed by the humans. Although this FMS is automated here, that is the operations and control system are being used here. So apart from that, so you must have human resource in order to make particular functions. So as I said, the flow lines. So the FMS is having a number of flow lines that is called as a layouts. So it has a number of layouts. So depending upon the space area and also depending upon the number of operations, if it is having a number of operations and if the part has to be transferred to the number of workstations, then depending upon that, so we are going to use the layouts. That is, there are number of layouts in a FMS. That is, first one is progressive or line type. So in the previous figures, so we can see the lines here, flow lines, which are of a line type. So there are line type layouts, or it may be loop type, or it may be ladder type layouts, and open field type and robot center type. So this is how the FMS layouts are being classified. So depending upon the number of operations, we are going to use a respective layout in a particular manufacturing industries, whether it may be of line type or it may be of loop type, ladder type, open field type, or robot centered type.